All right, so today we are starting our unit on algebra. You may have heard of this word before. It's actually an entire course that you will take whenever you are in ninth grade and then again probably in 11th grade. It's a topic that has a lot of coursework in high school, so it's important that we get a really good foundation and a good starting on it in sixth grade. So we are going to have 2 units over it. This is our first one, and our very first lesson to this is understanding variables, and like it says here, variables, right? Like, how do we say this? Well, the way that you pronounce this, very, like, ooh, that was very good. Like, and then bull, variable, right? So variables, what are variables? We're going to be understanding what they can represent and how to use them. But to start out, we're going to kind of lead this in something that we already understand how to do. So problem number 1. To ship a small box through Amazon.com, they charge $3. Question 1, part A, how much would it cost if you wanted to ship 2 boxes? Well, seems pretty straightforward. If I've got 2 boxes and each of those cost $3, to find the total cost, I take 2 boxes times 3, means I will be spending $6. Perfect. So, now it's kind of asking the same question, but instead of it being 2 boxes, now it is 6. Well, pretty much the same thing. I'm just going to take the number of boxes, 6 boxes times $3, means that I will be spending $18 to ship those. Then ask again for 12 boxes times $3 equals $36. And then for that last one, 17, it's the same thing. 17 boxes times $3. Well, I don't know that one. 17 times 3. 7 times 3 is 21. Carry my 2, 3, 51. So this one equals $51. Perfect. So all we did each time was we took the number of boxes and we multiplied that by 3. So the next part, write a sentence that describes how you could find the amount it would cost to ship any number of boxes. So yes, we're going to write a sentence. We're going to use our words. How can we find the amount it would cost to ship any number of boxes? So like, just basically, what's the rule? So I'm going to write to find the cost for any boxes, and then I'm going to go back and think, what was I doing each time? I did 2 times 3, 6 times 3, 12 times 3, so I take the number of boxes and I multiply it by 3. So I multiply the boxes by $3. Gave you a second to catch up if you haven't. We're just describing how we did it. All right, the next part is a 2-part question. Question part 1, what quantity is changing in the situation? So like, what are the amounts that are changing in the problem? And then the second part is what quantity is staying the same. So I'm going to just kind of like divide this into 2. So the first part, what is changing? So I'm going to go back and look. In each problem, there were things that were changing. When I look here, I see boxes, 2 boxes, 6 boxes, 12 boxes, 17 boxes. So the things that were changing, well, one of them was the number of boxes. But that also wasn't the only thing changing. When I look at my problems again, I see another thing that's changing. On each of these, I also had a different amount for my answer. And these numbers here represented the total cost. So it's the number of boxes and the total cost. So there's 2 things that are changing, the number of boxes and the total cost. On the other side of this question, it's asking what quantity is staying the same. So in this problem, there was some number that I was using that was never changing. It was always the same. And when I look back up here, I can see the number that I used every time that never was different was $3. And when that represents the cost for 1 box. So the cost for 1 box, aka $3. So why are we bringing up the things that are changing versus the things that are staying the same? Well, this, key point number 1, is going to explain. Key point number 1, variables are symbols we use to describe a quantity whose value is changing or varying. Okay, varying is just like a fancy word for changing, and it's actually, if you notice, it starts the same way that the word variable is. So it's varying because it's a variable. To represent a variable, we usually use letters. We use letters because if we use numbers, it wouldn't make sense because the values are never one particular number. So like in this case, the number of boxes was 12, but it was also 6, but it was also like 17, so it's never the same, so we use a letter. Key point number 2, there are 2 ways we normally decide what letter to use for our variable. You may be like, okay, cool, so instead of a number, we're using a letter. How do we know what letter? Well, the first way, we are given one by the problem. Most of the time, I feel like this will be the case. It'll tell you, use this variable for this. Okay, if it tells you what to use, that's what you got to use. You cannot just pick a new letter because you want to if they tell you which one to use. Okay, or if they don't tell you, you get to have a little bit of freedom and decide what it is, but you also have to write out what that letter is and what it represents. So if we go back up here and look, there was something that was changing each time, the number of boxes. If I wanted to make a variable for this, I want to stop and think, what is a letter that I might use to represent this? Well, boxes starts with the letter B, so if I wanted to use B, I'd say B equals boxes. And now I know anytime that I write the letter B, that represents the number of boxes. So sometimes it was 6, sometimes it was 3, sometimes it was 12. B is a changing number. It's any time that I want to represent the number of boxes, but it's not always the same number. Now I want you to pause the video here and look at the CFU, or the check for understanding. I want you to think, what's a variable that you might choose for these 4 problems? So take a second, try them out, and unpause the video whenever you're ready to check. All right, so checking these, the amount of hours that something takes. Well, hours, well, maybe we want to use something like H, because H is like the first letter of hours. Maybe we were like T equals time. Both of those would be good. I would probably go with H. Now you could use something like G or Z or F, it doesn't matter, as long as you write F equals hours. Okay, as long as you tell me what it equals, it's always okay, unless they tell you something else. The next one, the amount of dollars that something costs. So I would probably say D for dollars, or maybe C for cost. For a number of students in a class, I might say S is for students, or maybe I like to use C for class. Animals in a zoo, A for animals, maybe Z for zoo. So these are all good examples. Maybe you had some that are different. However, I also want to talk about something that we may have chosen that would probably not be acceptable. So I know you don't have room for this on your paper, instead we're just going to look it up here. So over here I'm going to write what would be unacceptable. So for dollars, some of us might have been like, all right, this equals dollars. It's not a number. Hey, this sign actually means dollars, so this wouldn't make a lot of sense to use for your variable because it also looks like you're labeling it with a unit. So don't use some like dollar sign for dollars. Use a letter. Another thing that we might have done is we might have said something like, I want to use A and I for animal. The problem with this is this looks like it's the variable A times the variable N times the variable I, which is totally different from just A and I for being animal. So if you want to use something for animal, it doesn't need to be 3. It can only be 1 letter. Okay, do not pick a variable that has multiple letters because then it looks like it's different variables. So just 1 letter. All right, moving on to key point number 3. An algebraic expression is an expression that involves at least 1 variable and usually numbers and operations. So we already know a variable. Then we also need to put in some numbers and operations. So like plus, minus, multiply, divide. So the check for understanding here, what could be an expression that we use for number 1 part E? Well, if we go back and look, number 1 part E was talking about the sentence right here that describes how to find the amount of money it costs to ship the boxes. Well, we already picked our little variable right here, B for boxes, so I'm just going to use that again. So what could be an expression? Well, I know my expression needs a variable, so here's my variable, B for boxes. It also says I need a number. What was the number that I was using each time? I was always using the number 3, and then the operation. Up here, what were the operations that I was using? 2 times 3, 6 times 3, 12 times 3, 17 times 3. So each time I was multiplying. And my variable, B. So my expression would just be 3 times B. I got a variable, I got a letter, I got an operation, and I got a number. Another way that we could write this, 3 with the dot, B, or the most common way that you're going to start seeing it is something that looks like this. The reason that we write it this way is because this is how it will look whenever you go to algebra in 9th grade, and again in 11th grade. It's how you'll probably always see it. Why is it written like this? Because first, we want the number, and then we want the variable. The variable always comes second. And remember, if there's nothing between them, we should already know that means it's being multiplied. So get in the habit of writing it with the number first and the variable second, because that's just going to be how we see it throughout the rest of our lives. All right, moving on to the next part. Key point number 4. An equation is a mathematical sentence that contains an equal sign. So it's pretty much the same thing as an expression, but it has an extra thing. It has an equal sign. So if you want to write a reminder to yourself, expression equals no equal sign, equation equals equal sign. An equation can be pretty easy to remember because it actually starts with the word equal, basically. All right, so moving on. Sometimes we evaluate or solve an expression and we turn it into an equation by adding an equal sign. So over here, we can see these are expressions. Why are they expressions? Well, they have numbers, they have operations, there is no equal sign. So these are expressions. Over here, we have equations. But notice, behind the equal sign, there's nothing. I put nothing here because this is actually going to be a point where you pause, and I want you to solve these 3 problems and tell me what they equal. We practiced GymDOS yesterday, so this should be a chance for you to review it, make sure that you remember the rules. When do you add? When do you subtract? When do you multiply? So pause the video here, and whenever you're ready to check your 3 answers, go ahead and resume. All right, let's check it out. First one, 15 plus 7 minus 3 times 4. According to GymDOS, we should hopefully remember, first thing, 3 times 4. So I have 15 plus 7 minus 12. Next thing, I would add because it is on the left. 15 plus 7 gives me 22. 22 minus 12 leaves me with 10. So for the first one, we should have gotten 10. So this is an equation because it has an equal sign. Next part, 14 divided by 7 plus 3 times 4. From GymDOS, I should remember, division is on the left, so I do it first. 14 divided by 7 is 2, plus 3 times 4. Next one, I multiply first because it is on it is above addition on GymDOS, so 2 plus 12 equals 14. And on the last one, it actually has 2 sets of parentheses. It actually doesn't matter which one you do first, but I'm going to do the one that's on the left. 17 plus 7 should give me 24, divided by parentheses 3 times 4. Next, I do the next parentheses, 24 divided by 12 leaves me with 2. So we should have gotten 2 for that one. All right, this next question, it's on your paper, but this is actually, I think, a little bit too advanced for what we're doing right now, so we're just going to kind of skip over this. We'll do more equations later in the future. Now I just want to look at the practice. So Frances is planning on having a party at her house. She wants to bake cookies as a snack, and she wants each person to have 4 cookies. So every one person gets 4 cookies. One person equals 4 cookies. Question 1, part A, how many cookies would she need to bake if she invites 6 people over for her party? Well, I know one person gets 4 cookies, so 6 people times 4 cookies per person means Frances is going to need 24 cookies. All right, question B, asking the same thing, but now it's 12 people. So 12 times 4 cookies means that she is cooking 48 cookies. Next one, 20 people, 20 times 4 cookies. Hopefully you can do this one in your head. Cover up the 0. 2 times 4 is 8. Put the 0 back. She needs 80 cookies. And the last one, 27 times 4 cookies. That one's harder to do. 27 times 4. 7 times 4 is 28. Carry my 2. 4 times 2 is 8. Plus 2 is 10. So she will need 108 cookies. I'm just going to leave it there so I don't write over it. All right, next part. Just like before, write a sentence that describes how you can find the number of cookies she would need to bake for any number of guests. So another sentence. We're using this to find the number of cookies for any number of guests. So to find the number of cookies, to find the number of cookies, I'm going to go back and look up. What did I do each time? Well, it looks like I did the same thing on all of them. I multiplied the guests by 4. All right, question F, what quantity is changing in the situation? What quantity is staying the same? This is, again, a 2-part question. So what is changing in the problem? When I go back and look, what was changing every time? Well, here I see 12 people, 20 people, 27 people, 6 people. So one of the things that's changing was the number of people. There was a second thing that was changing, 48 cookies, 80 cookies, 108 cookies. All of those were the total cookies. All right, the second part, what quantity is staying the same? So which one is not changing? When I go back and look, each time I did the same thing. I was multiplying it by 4, and that 4 represented the cookies. So 4 cookies per person. Perfect. All right, I know that yours is on the next page, so it may look a little bit different than mine, but it's the same question. Question G, write an algebraic expression for your sentence. Use G to represent the number of guests. Pause, go back and read this. Use G to represent the number of guests. Do I get to pick what I want for this one? No, I have to use G for guests. Guests equals G. I don't just get to pick whatever I want. Oh, actually, they gave me a capital G, so I'm going to put that. Capital G. I can't just pick some random letter. I have to use G because that's what they told us. After that, consider which operation you use to answer the first 4 questions. So when I go back and look, each time I was doing the same operation. Times 4, times 4, times 4. So we already know I'm doing something that is times 4. And the variable that they gave us was g. So g times 4. Now remember, this actually doesn't look the way that I had it before. Remember, this is technically right, but the way that would be better would be 4g. This is even better because it's in the right order. Question H, again, that part's a little bit too advanced for us today, so we're just going to skip over that, and we're going to instead go straight on to letter I. If Francis bakes 36 cookies, hold up. If Francis bakes 36 cookies, this is a different type of question. Now it's asking for something different. They're giving us the cookies, and it's asking for how many people can she invite. So I can't just do the same thing that I've been doing. Now I instead need to think, well, one person can get 1, 2, 3, 4 cookies. How many groups of 4 cookies would it take to get to 36? Well, 36 divided by 4. Hopefully we just have that memorized. Gives us 9. So how many people can she invite? 9 people. If Frances bakes 44 cookies, how many people can she invite? Well, same thing. I still have 4 cookies per one person. 44 divided by 4 gives me 11. All right, we've done a lot of practice and a lot of stuff for our introductory lesson. There's an entire another problem here about Miss Khan reading a book. I am not going to help you with this one. You're actually going to try this one without me now to see what we understand, and we'll come back and check it together as a class. Okay?